Take and record this so that way if someone has questions. I can get questions on here every week. You guys see the video camera on the wall? Okay. So we are going to take and do the offset formula or proportion formula. So in the book, it's this is addressed on page page 767 is where this is addressed in the book. Now we're not going to use the actual offset formula they give us in the book. We're going to modify it a little bit. So let's take a look at, we're going to do 25.25 in the book here. I'll lock the screen. So if you guys want to write down the particulars, I'll be writing them down too. You'll be able to get them when I write them down. So, all right. So 25.25. Let's talk about. Let's write down the things we know. G1 is a positive 4.50 grade. G2 is a positive 1.50 grade. We've got, let's see here, the PVI or VPI, they're synonymous, is, well, this is in meters, so I'm going to modify this equation a little bit and give it in feet. So I'm going to say it's 3,000. So we're going to modify it a little bit. The elevation of the PVI, I'm going to say is 672.0. Go some round numbers here. I'll just make one up now, I guess, because I don't want to be messing around in meters. And then our length of curve is going to be 650 feet. Okay. So if you pay attention there, we have G1 and G2 are both positive grades. What's that mean? In your problems, in your problems that you have for the homework, there's one that's 2 negative grades, I think. So basically what this is doing is the curve is looking like this, essentially. That's a little exaggerated, but it'll look like that. So this is G1 is equal to 4.50, G2 is equal to 1.50. L is 650. PVI or VPI, like I said, they're synonymous. BVC and EVC. Okay, so we can do this in a tabular form, sort of like the parabola formula. So I'll set up a table again, similar to parabola formula. Okay, so we're going to have the station, the tangent elevation, the tangent offset, and then the curve elevation. Okay, so those are the things we're going to figure out. Okay, so the first one's going to be the BVC. So we figure out the BVC the same way that we figured it out in the previous problems. So basically, just take the percent times half of L, and that's how much you're going to drop from PVI. So what's that end up coming out to be? I don't have my calculator in here. So what's our elevation of BVC? Might as well give me the station of BVC also. Elevation and station of BVC. Is the elevation? 657.38 is the elevation at BVC. What's the station? 2675. 26 plus 75. Okay? So our tangent offset here is the same. Well, first off, let's talk about the tangent elevation at BVC. The tangent elevation at BVC is the same as the curve elevation, because that's where the curve is attaching to the tangent line. So those two things are going to be exactly the same. Okay? The tangent offset here is going to be 0 because that's where the curve hits the tangent. Yes?
Remind me of the station, how you get that again?
The station. Okay. So it's the PVI minus half of L. Will give you the station of BVC. PVI station minus half of L will give you the BVC station. And then the PVI station plus half of L will give you the EVC station. All right, so we're going to figure this problem out in whole stations. Okay, so we'll go whole stations to the EVC. So we're going to end up going 27 plus 9, 30, 31, 32, and then 33 plus 25 is our EVC, right? Did I do that right? Okay. So the EVC, I just did PVI plus L divided by 2, or half of L. So the tangent offset here, how do we find that? Well, the tangent offset is that R divided by 2 times x squared. That's the tangent offset. Okay, so that's the same thing that is in the parabola formula. That same formula, I guess, to find that tangent offset. In the parabola formula, it's not known as the tangent offset. It's just a portion of that formula. But that's exactly what this is. It's a tangent offset. So what we're going to want to do before we figure out this tangent offset. Oh, by the way, the tangent offset for BVC is 0 because the BVC and the curve and the tangent are all together in that one point. So the tangent offset there is 0. That's why our curve elevation is the same as the tangent elevation. So now the thing that we're going to need to do when we go about creating or finding the elevations for the curve elevations, we have to find out all the tangent elevations at each station. That's all we're doing is taking the grade, that percent change, our 4.50 and timesing it by the distance that we went, okay, to get our change in elevation. So for every 100 feet I travel, I move 4.5 feet up, right? So I'm only traveling 25 feet here, so it's going to be it's going to be a fraction of that 4.5 feet. It's going to be like 1.25? 1.125 feet. So that we're going to climb an elevation, and then the next station will be the 4.5 feet. So we're going to want to figure out these elevations, and as you guys figure out these elevations, can you give me the elevations? Now, these elevations are on the forward tangent. I mean on the back tangent? I'm getting confused now on which one's which. It's on the tangent with the 4.5 grade, G1. So this tangent is basically going to be extended, okay? Because this is an offset method. This tangent out here really doesn't do anything for us besides help us find the elevation of EVC when we get there. So we're going to be figuring out stationing on this tangent line here as if it was extended, okay? So we're going to be way out here to find elevation of the EVC, the offset, and then we'll check with our math coming from the PVI to the EVC as a check to make sure we did it correctly. So we're going to be figuring out our stations along here, okay? So go ahead and fire off elevations as we go. Now these are on the tangent, so know that they're going to just keep on increasing in this example. Let's keep increasing. So whenever someone has 2,700, let me know. Two. 658.51. 653. You're going backwards, man. 663. Okay, 663.01. Okay.
667.51. 672.0.
Okay.
676.51. 681.0. That's what I got. 685.51.
Then the last one is an increment, 0.25, or 25 feet, I guess. Okay. So those are the elevations on that tangent line. These elevations that you figured out, so they're along this line. They have nothing really to do with curve elevation at all. Okay? So now, we're going to try figuring out the offset, the tangent offset, by finding R. So we have to find R, right? So R is equal to negative G, that's X, sorry. R is G2 minus G1 over L. Okay? So R is equal to 1.5 minus 4.5 over 6.5. L is in stations, right? No, it's in feet. This is what I did wrong last time. Is it in stations? 6.5. Okay. So R is equal to negative 0.46. Okay. So now X is our stations that we've moved. Okay. So for 27, when we figure out to 27 plus 0, 0, we're going to go 0.25 stations. So when we put x in this equation, it's 0.25 for the first one. And then the ones after that will be number of stations from that point. So it'll be like 1.25, 2.25, 3.25. So go ahead and fire off the tangent offset as we go, using R in there. You can give it to me in 2. Negative 0.01. Okay. Negative 0.36. Waiting on 29 plus 0, 0. Zero point. Now, 29 plus 0, 0.
I have negative 1.16. I want a confirmation though.
Negative 1.16. Anybody? Anybody? Okay. Negative 1.16. That was 29, sorry. 30. Negative 2.43. 31 plus 0, 0. $4.15. 32. Negative 6.34. 33. $8.98, and then our EVC 33 plus 25. Negative 9.72. All right, so notice they're all negative. The reason that is because we're in a crest curve. So we're going down to get to the actual curve itself. Now, if we were in a sag curve, those would all be positive numbers. Okay? So remember that. Those would all be positive numbers because you're going to be going up to the curve instead of down to the curve. So now, it's pretty easy to find the elevation on the curve here. So all we're going to do is take our elevation at the tangent and subtract this tangent offset. And that's going to give us our elevation over here. Okay? So this first one's an easy one. 658.50. So go ahead and fire them off as we go. Or as you go. 662.65. Nope, 68. 669.68 for the next one? Or 58? What is it? 58, okay.
$672.36.
74.
And the EVC. Okay, so let's check this number now by calculating the elevation of the EVC based off of its grade from the PVI. So it's going to be the grade times half L. That's going to give us our change in elevation. So it should change 1.5 feet per 100 feet. $76.88. So there's a rounding error in there somewhere. So we have a slight rounding error in there somewhere.
Probably because we round our offsets
To 2 decimals, yeah. So where this is practical to use is like if we're out in the field, it's pretty quick to figure out what the actual tangent elevation is. And then we can figure out that tangent offset based on the given. We don't have to go through that big long process of the parabola formula to get to those elevations. So this is just another method to equations, or this particular curve. Now in your homework, I can't remember what problem it is. Let me see if we can find it quick. But you'll have to do that particular problem via this method. It is problem Problem 4, you'll have to do the offset method. And then problem 6, you're doing both offset and parabola methods. So problem 4 is the offset method. That's this method that I just showed you. Okay. Now if you look at them side by side, these methods, side by side, so here, let's see if we can squeeze them together here.
Why are we using it?
Just to get used to both. So if we squeeze this over further, so this is the parabola method. There's a couple extra steps in there. This is the offset method. So there's a few less steps with the offset method than there is with the parabola method. So when you're going about doing your homework, make sure you pay attention. It says in there whether you're using the offset formula or the parabola formula. Anybody else want me to do another example? Yes. Okay. Example 7 in the homework.
I was wondering what do you use for X here?
Let's take and work on 25.6 out of the book, which you guys don't have the book, but we did the parabola formula for this one last week. So we have our answers already for this one, so we'll see how we come out. Okay? So let's, we'll do the offset formula or the proportion formula. Okay, so this one was 25.6. And we had a curve that looks something similar to this. And G1 is equal to 2.00. G2 is equal to negative 1.50. The VPI is 78 plus 60 and has an elevation of 7855.35. We have our curve. L is 455 feet. Okay. So I think that's everything that we know about the curve. So let's start by calculating our station and elevation of BVC. Okay? So the station at BVC equals the VPI or PVI, I use them interchangeably, minus L divided by 2. So that's our station at BVC. So that's going to be 780 plus 60, or 78 plus 60 minus 455 divided by 2. 76 plus 42.5. 32.5, isn't it?
Yeah. It's 32.5.
32.5. 76 plus 32.5. So this is 76 plus 32.5. I gotta sharpen this pencil quick. Also.
Oh, 55, right.
Alright. So just for grins, let's figure out the EVC elevation. So our EVC is equal to the BVC plus L. So it's 76 plus 32.5 plus 455. That should equal 80 plus 87.5. Okay? Alright, so let's find our elevation at BVC then. It equals, let's see here, it's L divided by 2 times G1. So that elevation at BVC is what? C.80. Okay, so we have our elevation. So let's go ahead and make our grid here. All right, so we have station, tangent elevation, the tangent offset, and then the curve elevation. And remember that this is r divided by 2 times x squared is the tangent offset. So we already figured out our first station, the BVC. Let's go ahead and populate that in there. So that's 76 plus 32.5. We already figured out that elevation, so tangent elevation was 7850.80, which is also the same as the curve elevation, 7850.80, and we know that our offset is 0, so we can fill out the whole thing for BVC. Alright, so let's go full stations. We're going to go 77 plus 00, 78 plus 00, 79 plus 00, 80 plus 00, and then the last one, 80 plus 87.5, which is EVC. Okay? Alright, so remember, the tangent elevations we're figuring out on the tangent. So we're going to move along this tangent line all the way out, you know, like we're extending that tangent. So let's go ahead and figure out our elevations at each station along that tangent. So the first one is going to be times, 67.5, or 0.675? Or 60, it will be 67.75. So that'll be the first one that we're going to have to add to go up that tangent line. Okay. That's for 77. How about 78? Should be 78, 50, 4.15. Is that correct? Remember, I don't have a calculator up here. Anybody concur with my number for 78 plus 00?
2 feet every 100.
2 feet every 100, so it would be right, right?
Did we concur with my first answer? Okay.
What's our last one then for EVC?
78, 59.9.
90?
Sure.
Okay, so the EVC's elevation on the tangent elevation is 7859.90. Everybody concurs with that? We're ready to move on. Okay, so now we're going to figure out the tangent offset. So we have to figure out R again. And R we know is equal to G2 minus G1 divided by L. L. In stations. So R equals negative 0.769, right? Okay. So now we're going to plug R into this equation, and X here is our change in stations. Okay? So for here, it's going to be 0.625, or 0.675, sorry, will be x. So who can give me the tangent offset for 77 plus 0, 0?
Maybe that's 2 or 3.
Give me 3.
Negative 0.175.
Okay? How about for 78?
Negative 1.07. Negative 2.751.
Okay? Next one's negative 5.194. Okay. And then the last one?
Negative 7.960.
Alright, so we solved the tangent offsets. Now we can figure out our curve elevation. So it's our tangent elevation plus our tangent offset will give us our curve elevation. But we're adding a negative, so it subtracts. Okay? So 77 plus 0, 0 should be what? 78, 51.98 rounded, right? How about 78 plus 0, 0?
Negative 53.07.
Okay, 78, 53.07. 79 plus 0, 0.
78, 53.4.
40. Okay, 78, 53.40. 80 plus 0, 0. 78, 53 or 52?
52.
2.96, okay. And then the last one, 78, 51.94?
Yeah. Yeah, that's check.
Okay. And then if we do the math back here, will we be able to check to make sure that checks, or did you guys already do that calculation? Okay. So if we take, just so everybody understands that, if we take the VPI, or from the elevation from the VPI and figure out with the grade, we can figure out the elevation at EVC, and then we can do that as a check there, right? So, and evidently it checks okay. So, everybody grasp that.